Granulate is a real-time continuous optimization platform. We achieve cost savings by improving the performance of your applications. We typically see that customers that engage with Granulate save up to 45% on their compute costs. But what's really significant here is that it's all done with zero code changes. That means your development team does not need to modify their code or do any redevelopment. All of these changes are happening autonomously at the runtime level. We'll talk a little bit about how that actually works. So our technology is an agent-based solution. Depending on your architecture, we'll deploy an agent into the environment that is installed on each VM or instance within the environment. That agent will do workload discovery, find the application runtimes that are running in that environment, and install an appropriate runtime module on each of those running applications. We typically support JVM-based workloads, so Java, Scala, Kotlin, etc., as well as Python and Go. Once the runtime module is installed, we go into learning mode, where the module will start learning the resource scheduling mechanisms in place by that application today. So for JVM-based workloads, as an example, we may look at thread execution order. By default, the JVM does first in, first out, but we may, by profiling the application, we may identify which threads would be better suited to be reordered in a different execution order, with the result of reducing the overall wait time that threads spend waiting on the CPU. The agent is collecting information in 20-second batches and sending that information to Granulate's backend, where we do the resource-intensive learning processes. Once learning is complete, we are then able to load the optimal configuration back to the agent. And once we activate, you are now realizing the performance optimizations while the agent is making runtime decisions. These are a few examples of runtime optimizations in a JVM-based workload. We already talked about thread scheduling at the bottom of the screen. And maybe one other example here is the crypto and compression optimization. We are able to more finely tune the parameters of compression at the thread level, while your developers may be doing it at the process level. So the agent has more granular control over these parameters, reducing the CPU footprint or optimizing when compression is taking place. So to talk a little bit about the process, how do we engage? We start by profiling your application with an open source profiling tool. And this allows us to provide you with an estimate for a given application. What do we expect the optimization potential to be? We may come back to you and say, we believe for this application, we can achieve 23% performance improvement, at which point we would then install the agent, go through that learning process, and activate the optimizations. We would then do a benchmark where we are comparing 1 week prior to activation with 1 week after activation to qualify and validate that we are able to achieve the optimization potential that we sought out. To go from performance improvement to cost reduction and capacity management really depends on your architecture. If you are auto-scaling, you'll automatically realize the cost reduction because you will simply not hit your scale-out thresholds nearly as often. If you're not auto-scaling, then there may be an additional step that we need to take to resize the cluster or resize the environment so that you're reducing your cost footprint in addition to reducing your CPU utilization. In addition to the application layer optimizations, we also provide a capacity management solution that will help in Kubernetes-based environments, including Red Hat OpenShift, where we can intelligently set CPU requests on a per deployment basis. This helps reduce the over-provisioning gap, which further reduces costs. So now we are able to reduce costs both at the application layer as well as the orchestration layer. Finally, to talk about the use cases that we see most improvement with, we've spoken about the API-based workloads on the top left here, JVM-based workloads, Python and Go, where with a 1 week learning period, we typically see improvements of 30 to 40% at the application layer. Another area that we see some pretty good improvements is in big data workloads. These are also JVM-based Spark workloads. The learning period is a little bit longer, about 2 weeks, but we are able to return typically 25 to 30% performance improvement and reducing the job completion time of these workloads, which in turn reduces cost. Thank you very much for watching. Please feel free to reach out with any questions.